Our planet is sending a chilling message from Antarctica, a place often thought of as a frozen, unchanging wilderness. In late 2022 and early 2023, scientists witnessed the Hektoria Glacier collapse at a speed never seen before. The rapid disintegration left experts stunned and concerned. This was not a slow melt, but a violent disintegration. Nearly 5 miles of glacier vanished in just months. The sheer scale and speed of the collapse were unprecedented. Glaciologists called it unprecedented, a catastrophic failure that shattered assumptions about ice stability. The event has forced scientists to rethink their models and predictions. For years, such rapid collapses were thought to be ancient history, not something we'd see today. The historical data seem to suggest a more stable ice environment. The event signals that Antarctica's ice systems are far more fragile than we believed. This newfound fragility has significant implications for our understanding of climate change. The collapse is a warning. The ice locked in Antarctica could raise global sea levels dramatically. Coastal cities around the world are at risk. Each glacier that weakens adds to this threat. The cumulative effect could be devastating if we do not take action. Hektoria's collapse is a preview of what could happen to even larger glaciers. The potential for more significant collapses looms large. It's a wake-up call to pay attention to changes at the bottom of the world. The scientific community is urging immediate and sustained attention. What happens in Antarctica will affect us all. The interconnectedness of our planet means no region is isolated from these changes. The time to heed these warnings is now. Our future depends on the actions we take today. To truly grasp the gravity of Hektoria's collapse, we first need to understand what makes this glacier so significant, not just for Antarctica, but for the entire planet. Hektoria Glacier is a vast, ancient river of ice, shaped over thousands of years by relentless cold and pressure. Its surface is a frozen landscape of deep crevasses and shimmering blue ice, a testament to the forces that have sculpted it. Located on the rapidly warming Antarctic peninsula, Hektoria is at the front line of climate change where rising temperatures are felt most intensely. Once, Hektoria covered an area as large as the city of Swansea in the UK, making it a true giant among glaciers. For centuries it was held in check by a floating ice shelf, a natural barrier that slowed its movement and kept its mass stable. This ice shelf acted like a cork in a bottle, preventing the glacier from flowing freely into the sea. But when that shelf disappeared, everything changed. Suddenly unrestrained, the glacier began to surge toward the ocean, accelerating at an alarming rate. Hektoria is hundreds of meters thick, towering walls of ice that dwarf anything around them. As it moves, it carves through mountains and grinds over bedrock, dragging rocks and debris along its path, reshaping the landscape beneath. The recent collapse saw its front section shatter, disintegrating into a chaotic jumble of icebergs that now float in the frigid sea. Nearly half its ice mass vanished in just a few years, a dramatic testament to the relentless power of warming forces at work. Not long ago, Hektoria wasn't considered especially dangerous. It was seen as relatively stable, unlikely to contribute much to sea level rise, but its rapid and unexpected retreat has forced scientists to rethink what's possible and what risks even medium-sized glaciers can pose. The truth is, even glaciers that seem modest in size can behave unpredictably, with consequences that ripple far beyond Antarctica. Today, Hektoria's story is central to our understanding of climate change, offering a stark warning about the speed and scale of transformation possible in our warming world. It stands as a clear example of how quickly our environment can be reshaped, reminding us that the fate of distant glaciers is deeply connected to our own future. Hektoria's collapse is the latest chapter in a story that began in 2002. That year, the Larsen B ice shelf, stable for 10,000 years, shattered in weeks. The shelf had acted as a barrier, holding back glaciers like Hektoria. When it vanished, the glaciers behind it sped up, freed from their icy brace. For 2 decades, these glaciers thinned and accelerated, setting the stage for disaster. The Larsen B collapse was a landmark moment, showing how sensitive Antarctica is to warming. Hektoria's 2022 is a direct consequence of that event. The glacier's foundations were slowly eroded by warming ocean waters. The final retreat was the result of years of hidden decay. This chain reaction shows how interconnected and vulnerable Antarctica's ice system truly is. The secret to Hektoria's rapid collapse lies beneath the ice, hidden from the naked eye and often overlooked. The glacier rested on a flat plain below sea level, a dangerously unstable setup that made it vulnerable to changes in the ocean. As long as its front edge was anchored to the sea floor, it stayed stable, holding its ground against the forces of nature. But warm ocean water melted the glacier from below, thinning the ice until it began to float, destabilizing the entire structure. Once the glacier lost its grip, a runaway chain reaction began, leading to a rapid and unstoppable collapse. The process is called marine ice sheet instability, and it's driven by ocean heat, not just air temperature. This makes it particularly insidious. Hektoria's front edge lifted off the bedrock, exposing it to the full force of the ocean, accelerating its disintegration. With no new anchor points, the glacier retreated rapidly, like a car rolling downhill, with no brakes. Unstoppable and inevitable. This mechanism is especially worrying because it's hidden from view, unfolding beneath the ice, out of sight and often out of mind. The speed of Hektoria's collapse shows how quickly this instability can take hold, transforming the landscape in a matter of years. Our models underestimated how fast glaciers can fail once this process starts, revealing gaps in our understanding and predictions. The real threat to Antarctica's ice may be the warming ocean below, not just the air above, a factor that demands urgent attention. Hektoria is a stark reminder of that hidden danger, a warning sign of what could happen to other glaciers if we do not act. Scientists captured Hektoria's collapse using advanced technology. Satellites tracked the glacier's retreat with stunning precision. Radar mapping revealed the vulnerable flat bedrock beneath the ice. Seismic sensors detected tremors as the glacier's anchor to the continent was torn away. These weren't earthquakes, but the sounds of the glacier's foundations failing. The data confirmed that grounded ice that raises sea levels, was being lost. Aerial surveys in 2024 showed the aftermath shattered icebergs and a jagged new cliff. This combination of space, ground, and air data gave scientists a complete and alarming picture. Hektoria's collapse involved a relatively small amount of ice, but its warning is enormous. The same conditions, flat bedrock below sea level and warming ocean water, exist under some of the world's largest glaciers. West Antarctica's Thwaites and Pine Island glaciers are now the focus of concern. Thwaites, the Doomsday Glacier, is the size of Great Britain and could raise sea levels by over half a meter. Like Hektoria, it sits on a deep basin below sea level. Scientists warn that Hektoria's rapid retreat changes what's possible for these giants. If Thwaites were to collapse quickly, the consequences would be catastrophic for coastal cities worldwide. Hektoria is a real-world preview of this worst-case scenario. Our models may be underestimating how fast these massive ice sheets can respond to climate change. The lesson: we must be ready for rapid, dramatic changes that could reshape our coastlines. In the wake of Hektoria's collapse, scientists are sounding an urgent alarm. We need better monitoring, more advanced satellites to track the critical grounding lines where instability begins. Computer models must be updated to account for the potential of rapid, runaway collapse. This means gathering more data from the ground, air, and beneath the ice. Robotic submarines are needed to measure ocean temperatures and currents where they do the most damage. But this isn't just a scientific challenge, it's a global one. The warming ocean that triggered Hektoria's collapse is a direct result of excess greenhouse gases. The only way to protect the world's ice is to slow and reverse global warming. Antarctica may seem distant, but its fate is tied to every coastline on Earth. The scientific community is doing its part to sound the alarm. Now the world must listen, before more dominoes fall.